our next chemical property in arenes is addition reaction. Generally, arenes and its homology do not give addition reaction easily. It is because of the delocalization of the pi electrons. Because of delocalization of pi electrons, these electrons are not available for addition reaction. Because of that, they are not giving addition reaction like alkenes and alkynes. But in drastic condition, arenes give addition reaction. There are few examples of addition reaction which we have earlier studied in determining the structure of benzene. So first reaction which we will be going to study in addition reaction, that is reduction of benzene. Benzene, when reacted with hydrogen in the presence of catalyst, either ranitidine or platinum, either these of the two catalysts can be used. The temperature of the reaction is 473 to 523 Kelvin. So there is formation of cyclohexane is taking place. So this is the example of addition reaction. This is the first reaction. Next, second example of addition reaction in benzene is addition of halogen. This reaction is taking place in the presence of sunlight or heat. In this reaction, there is absence of halogen carrier, that is Lewis acid. If there are Lewis acid is present and the reaction is taking place in the low temperature, then there is electrophilic substitution reaction is taking place in benzene. Whereas if the halogen is reacted with benzene in the presence of light or temperature, then there is addition reaction will takes place. So what is happening in this case? In this case, 3 mole of chlorine react in the presence of sunlight. So when there is presence of sunlight, then the reaction will be addition reaction, 500 Kelvin temperature. So there is a formation of hexachloro. So there is formation of benzene hexachloride is taking place. In this case, this compound is saturated. So what is happening in this case? In this case, each carbon is attached by one chlorine atom and one hydrogen. So this cyclic compound is saturated, which represent that there is addition reaction is taking place. Next chemical property in arenes is oxidation reaction. First oxidation reaction is complete combustion. So what is happening in this case? Arenes are completely burned in the presence of air or oxygen with a yellow luminous shooty flame. It means because of the higher carbon content, there is a shooty flame is produced. So in this case, what is happening? When benzene C6H6 is heated in the presence of oxygen, so there is a formation of complete combustion will takes place. It means there will be formation of CO2 and H2O. In this case, there is a large amount of energy is released. So what is happening in this case? There is a large amount of energy is released, that is 3000 kilojoule per mole of energy is released during this combustion reaction. So what is happening? First of all, you have to balance the reaction. There are 15 moles of oxygen and 2 moles of benzene are taken, which will produce 12 moles of CO2 on combustion and 6 moles of H2O. You have to always balance the reaction. So in this case, when benzene or higher homology of benzene are burned in the presence of oxygen, then there is a yellow luminous shooty flame is produced, which is used for qualitative test for distinction of aromatic hydrocarbon from aliphatic hydrocarbon. Next is incomplete combustion of arenes. So what is happening in this case? Benzene is heated in the presence of limited supply of oxygen. In this reaction, there is a catalyst is also used, that is vanadium pentaoxide, and the temperature of this reaction is 773 Kelvin. So there is a formation of CHCOOH. This is a malic acid. So there is formation of malic acid will takes place, and Further on heating, this malic acid will give malic anhydride. So further on heating, this malic acid will give malic anhydride. So this reaction is example of incomplete combustion. This reaction is taking place in the presence of catalyst, that is vanadium pentoxide, and the temperature of the reaction is high, that is about 773 Kelvin. Next oxidation reaction in arenes is done by the help of KMnO4, that is potassium permanganate. We know that arenes are unaffected of Bayer's reagent, that is alkaline dilute cold KMnO4. It is known as Bayer's reagent. Bayer's reagent give test with alkenes and alkynes, but with aromatic hydrocarbon they do not give test. It means the pink color of KMnO4 will not decolorize to brown precipitate, that is magnesium oxide, in the presence of aromatic arenes. So this is used as a distinction test between the aromatic hydrocarbon and aliphatic alkenes and alkynes. But higher homology of benzene give reaction with hot alkaline KMnO4, whereas benzene will not give reaction with hot alkaline KMnO4. So let's see how the reaction is taking place when we take hot alkaline KMnO4. So what is happening in this case? If higher homology are taken, so what is happening in this case? The side branch of this higher homology of benzene, that is toluene, will be oxidized to carboxylic acid in the presence of hot alkaline KMnO4. So what is happening in this case? If first this compound will react with hot alkaline KMnO4, so the temperature of reaction is 373 to 383 Kelvin. Further acidic hydrolysis of this compound will be taken place in the presence of dilute H2SO4. So the final product which will be obtained is benzoic acid. So what is happening in this case? This benzene ring will remain unaffected in the presence of hot KMnO4, whereas the side chain part of the benzene ring will oxidize to carboxylic acid. It doesn't matter what is the length of the side chain, it will always oxidize to give carboxylic acid. So what is happening? If there is a longer side chain is present, still it will produce benzoic acid. So what is happening? If we take CH2, CH3, this reaction is taking place in the presence of hot KMnO4, alkaline KMnO4. The temperature of the reaction is 373 to 383 Kelvin. Further, there is acidic hydrolysis will be taking place in the presence of dilute H2SO4. So the final product which will be obtained is benzoic acid. So irrespective of the side chain length, there will always be formation of COOH. So always there will be oxidation of this carbon will be taking place, that is first carbon which is directly attached to benzene ring. It will oxidize to give benzoic acid. So what is happening? In this case there is one more carbon and hydrogen. So these carbon hydrogen will also oxidize to give CO2 and H2O. So you have to balance the reaction. Further, if we take this compound, this is 1,2-dimethyl benzene, or it is also known as ortho-dimethyl benzene. So what is happening in this case? There will be formation of, if oxidation in the presence of alkaline, of dilute H2SO4. So the final product which will be obtained, because in this case there are two methyl groups which are present at ortho position. So both the carbon which are directly attached with benzene ring, they are oxidized to give COOH. So this CH3 will oxidize to COOH. This compound is known as phthalic acid. If we take metaxylene, metaxylene is the common name of this compound, and metaxylene is oxidized, similar condition, then there will be formation of COOH, COOH. This is isothalic acid. If we take paraxylene, so what is happening? If paraxylene is oxidized in the presence of hot KMnO4 and further acidic hydrolysis will be done, so there is formation of terephthalate acid. This is terephthalate acid and removal of H2O. Similarly, in this case also there will be removal of H2O. Every time whenever you write the reaction, you have to balance the reaction. Next oxidation reaction in benzene is Etard reaction. This reaction is named reaction, so it is important. So this reaction is taking place in the presence of mild oxidizing agent, that is chromyl chloride. So what is happening in this case? So toluene will react with first, that is mild oxidizing agent chromyl chloride CrO2Cl2 in the presence of inert solvent. So inert solvent can be carbon disulfide or we can also use CCl4. Further, the compound which will be obtained is hydrolyzed. So there will be acidic hydrolysis will be done of that compound which will be formed by the addition of this chromyl chloride. So further hydrolysis in the presence of acid is taken place. So there is formation of final product will be aldehyde. So this is aldehyde, that is benzaldehyde will be formed in this. This reaction is Etard reaction. So how this reaction is taking place? This reaction is taking place in two steps. In first step, this compound toluene is reacting with chromyl chloride CrO2Cl2 in the presence of inert solvent. So there is a formation of this combined product is taking place which is unstable. So this product will be formed. Further, what is happening? This compound will be hydrolyzed in the presence of acid. So acidic hydrolysis will be done. So there will be formation of. So in the presence of acidic hydrolysis, what is happening? There is one hydrogen which will remain intact and these bonds are cleaved. So there will be formation of, it means there will be two hydroxyl group which will be attached to same carbon. And you know that more than one hydroxyl group on same carbon is unstable. So what is happening? There will be removal of water will be taking place. It means there will be removal of water. And further there is one oxygen is left, so there is formation of carbon double bond oxygen. Because of that there will be formation of benzaldehyde is taking place. Next oxidation in arenes is done by the help of ozone. So this reaction is ozonolysis. So what is happening in this case? We know that in the case of ozonolysis, there is requirement of pi bond. 3 moles of ozone molecule are taken in the presence of inert solvent, that is CH2Cl2, and the temperature of reaction is 196 Kelvin. So there is a formation of ozonoid compound is taking place. So the double bond position, in the double bond position both sigma and pi bond will be cleaved, whereas the carbon which are shown by the single bond will remain intact. It means this bond will remain intact between the carbon. So what is happening? This bond is remain intact. So this bond will remain intact, whereas these carbon will form ozonoid. It means there is a formation of tri-ozonoid compound will be taking place. So this is the tri-ozonoid compound which will be formed. Further on, reductive cleavage in the presence of zinc dust and water. So there will be removal of 3 moles of ZNO. So how this reductive cleavage is taking place? In this case, in the presence of zinc dust, there will be homolytic fission will be taking place. We know that oxygen, single bond oxygen is unstable, so there is homolytic fission is taking place. This oxygen bond will homolytic fuse. It means both the oxygen will take away the shared pair of electron, so there is homolytic fission. Similarly, this oxygen is also bonded by the single bonds, so there is also homolytic fission. Both the atom which are bonded by the single bond, this oxygen will take away its electron of the bond, and this carbon will also take away one electron of this carbon oxygen bond. In this case also there will be homolytic fission. So what is happening? Further there will be formation of carbon oxygen double bond. In this case also carbon oxygen double bond. Similarly in this case, so there is a formation of 3 moles of glyoxal is taking place. Next chemical property in arenes is pyrolysis. In this case, arenes are heated at very high temperature. So what is happening? Example. So what is happening in this case? This reaction is taking place in the presence of pumice, and temperature of the reaction is 873 to 1073 Kelvin. So the pyrolysis will be taking place, and there will be formation of this diphenyl will be taking place, and removal of 2H. Recent method for the preparation of diphenyl is done by the help of mixture of benzene, and superheated steam is taken, and this mixture is passed over the steel tube which is internally coated by Fe2O3. So there is formation of diphenyl is taking place. In this case, benzene fumes are heated to 923 Kelvin, whereas steam is heated to 1373 Kelvin.